Hi everyone, this is your math guru. In this video, I'm going to use the knowledge of geometric sequence or series to solve the following area of shaded region question. We have the diagram represents a sketch of circles. Half of the area of each circle is shaded as shown. The radius of the largest circle is 2 units. The diameter of each smaller circle is equal to the radius of the previous circle. Determine the sum of the shaded areas of all the circles in this process going on indefinitely. That's the sum to infinity. Give your answers in terms of pi and simplify. To start, the area of a circle, the formula is equal to pi radius squared. And therefore, to find the area of a semicircle, that's half of a circle, the formula will be half of the area of a circle, which is half pi r squared. If I go back to the diagram and I tag the outer circle A, the next one B, the next one C, and so on, going by the statement given, it says the diameter of each smaller circle is equal to the radius of the previous circle. So what that means is the diameter of each smaller circle, the next smaller circle after A, is B. So therefore the diameter of B is the radius of the previous circle. So therefore the diameter of B will be 2. Therefore the radius, which is half of the diameter, R for the B, will be 1. If I go to C, because 1, which is the radius of the big circle B, will be the diameter of C. To find the radius, R will be half of 1, which is 1 over 2. So what happens is, for each iteration, the radius will be half of the previous radius. So therefore, to determine the sum of the shaded areas of all the circles, starting from the first circle, we have sum of areas. Note that the areas in this case are the semicircle. We have the first semicircle that will be equal to the area of the first semicircle, that's half pi. Note that for the first semicircle, which is A, the radius is 2. So I have that as 2 squared plus the second semicircle, that's half times pi times radius squared. The radius of the second semicircle, which is a B, is 1. So I have that as 1 squared. Plus for the third one, I have half pi radius squared. Radius of the third semicircle, that's R, equals 1 over 2. So I have that as 1 over 2 all squared. Plus that goes on. Therefore, simplifying, I have the sum of areas equals half times pi 2 squared, that's 2 times 2, which is 4, plus half times pi 1 times 1, that's 1, plus I have half pi, half squared, that's 1 over 2 times 1 over 2, that's 1 over 4, and that goes on. Simplifying, I have 2 here 1, 2 here 2. I have 2 pi plus half pi plus 1 over 8 pi plus that goes on indefinitely until you get to the last circle. In this expression, I have my first term. I have T1, that's area of the first semicircle. I have T2 and T3. So what that means is, to use the sum of to infinity of a geometric sequence, I start by finding my A, the first term, which is T1, and that is 2 pi. My common radius, R, is equal to the term in front, T2, divided by the term behind, that's also equal to T3 over T2. So I can use either. I'm going to use T3 over T2. So that's 1 over 8 pi divided by T2. That's 1 over 2 pi. Simplifying, I have that as 1 over 8 pi times 2 over pi. I have pi divided by pi, that's 1, 2 here 1, 2 here 4. Therefore, my common radius, r, is equal to 1 out of 4. Note that if my r is 1 over 4, then I have minus 1 is less than r, which is 1 over 4, and 1 over 4 is less than positive 1. So therefore, the formula to use will be sum to infinity of a geometric sequence or series is equal to a over 1 over r. If my r was greater than 1, then it will have been a over r minus 1. If I slot in the parameters, I have my a to be 2 pi. So I have 2 pi divided by 1 minus r. R is 1 over 4. That's equal to 2 pi divided by 1 minus 1 over 4. That's 3 over 4. Therefore, I have that as s to infinity equals 2 pi times, using the fraction rule, I change my division to multiplication, and then I switch the right hand side. I swap it, so that's 4 out of 3. Simplifying, therefore, my sum to infinity is equal to 4 times 2, 8 pi over 3 square units. So note that if you go back to the question, it said determine the sum of the shaded areas of the circles. If this process goes on, the word there is indefinitely, and give your answers in terms of pi and simplify. So our final answer will be s to infinity equals 8 pi over 3 square units. Thanks for watching. Bye.